Now when it comes to merge sort, okay, basically you can see, okay, basically you can see here, to combine two subarrays, to combine two subarrays in the merge sort, it takes, to combine, okay, I will write like this, to combine two subarrays, okay, takes more time, correct or not? Takes more time, but more time, but to divide array into two subarrays takes constant time. Yes or no? For example, consider this is an array, okay, A n minus 1. To divide this array, so how much time it is required? Very simple. What is that exactly? I plus j, okay, divide by 2. This is the constant time actually. Yes or no? This is the constant time we are taking to divide the array. But that's what, if I divide this array into n number of subgroups, nothing but subarrays, to combine those two subarrays, it takes a lot of time. Okay, this is what exactly I'm talking about. If I want to combine these two arrays, sorted arrays, okay, so then what is the time it will going to take? It will going to take a lot of time. That is the problem here. Okay, biggest problem. What happens here? There is an algorithm, merge sort algorithm, merge sort algorithm. Okay, so in the inside the merge sort algorithm, there will be a one more algorithm that is called it as merge algorithm. Okay, understood everyone? This is very, very important line I'm talking about. Just now, still I'm talking about only merge algorithm. I haven't discussed anything about merge sort algorithm. So we will see this one. That is what exactly I am popping this technique here. What is that exactly? If I have a two subarrays like this, one subarray here, another subarray here. Okay. So when you want to combine these two sorted arrays, sorted subarrays, it's take a lot of time. That is what we call it as this merge function. Okay, merge function. Till now, I am talking about only merge function. I haven't discussed anything about merge sort first of all. Okay, so please understand this. Only I am talking about merge algorithm right now. I wanted to combine these two sorted arrays. So that's why to merge this one, it takes a lot of time, but to divide this array into two subarrays, it takes constant. Be careful this line, okay? Again, when you want to combine here, I wanted to combine this array with this array. Suppose example, what I will going to do, take an array like this. I will going to divide into two parts. Now it is a sorted one. I will going to apply algorithm for both. What is that algorithm? Merge. Okay. Merge algorithm I will going to apply here. To combine these two sorted arrays, what I will going to do, I will going to write an algorithm for this here. I will going to write an algorithm. So according to that algorithm, it will going to merge. That one we will call it as function or not. Okay. So that is a merge function. What it will do, it will going to have an inside the merge function, it will going to have a loop. Okay. It will going to have a loop. Yes or not? It will going to have a loop. Nothing but what? Here exactly what I'm talking about. If n number of elements is there, it will take const to execute that merge algorithm plus and to compare, and there are n number of elements are there. Each and every element I have to compare. Again you have to merge it. It will take totally constant plus n. So finally what, n times it will take n. Okay, but when you go to the this one, please observe this line is very, very important. Everybody observe here. Suppose if you go to this one, what is that? Basically go to the binary search. You take it binary search. Okay, binary search, you take it. Do you find any kind of combine here? Nothing like that. Just you have to divide the array. Okay, if the element available in this side, nothing but right side, okay, right side, just what we'll want to do, mid plus 1. If the element is available here, what we'll want to do, just mid minus 1, right? So this is what we will do. But here when it comes to merge algorithm or merge sort, there is an algorithm, merge algorithm. So what it will do, merge algorithm basically, so inside the merge sort there will be algorithm, so that using that algorithm I will going to sort two subarrays. Okay, this is one array, this is one array, so nothing but n by 2, n by 2. Okay, understood? I think everybody got this one, yes or not? Now let's see further about this. Whatever the things I discussed, now we will going to discuss briefly about this. What is that? What sir is talking about merge algorithm, all those things. We will going to write the algorithm also. Don't worry. So I will show you everything. No need to worry. Now see here, everybody observe here. Let's take an array. Suppose example, I will going to take an array here. Okay, let's take an array like this. Okay. Okay, let's take indexes also. 1, 2, 3, 4, 5, 7, 8. Okay, one more extra. Remove this, not required for me right now. Okay, so this is a array. Right now, please understand this is an array. But what I will going to do exactly, please understand what I will going to do. I divided this array. If you go to the previous explanation, you will going to understand this is a divided array, nothing but what exactly I taken a array that is divided into two parts, nothing but this is n by 2, it will going to do n by 2, n by 2, like that. I divided. Finally I will going to combine. What you will going to get it, you will going to get a sorted array, you will going to get a sorted one. Okay, there is a, how many sorted arrays are there? Two sorted arrays are there in this. You can able to see there are two sorted arrays. There are two sorted arrays. Yes or no? There are two sorted arrays here. So let me write the numbers also, so that you can able to get it very easily. Okay, 10, let's take 10, 20, again 30 also, again 40. Okay, now let's take any number. 11, 21, okay, 31, 41 here. Clear everybody? Everybody got this one? So we have a sorted array here. How many sorted arrays are there? There are two sorted arrays are there. Here you can able to see one, you can able to say M, another one you can able to say N. That's fine, no problem. How many elements are there? Totally 4 elements are there here. Again here also 4 elements are there. Correct? Yes. Okay. Now I will going to consider the index value for this one. I will going to make it as I here. No problem, right? Everybody okay, right? Again this one I will going to consider as mid here. Okay, no problem, right? Everyone. From this side, this is one array. Okay, this is one more array. Okay, from this side I will going to say mid plus 1. Correct? Mid plus 1 from here. Again up to here n I will going to say. Okay, again where it will going to start, it will going to start from here, j also you will get it, no problem. Okay, fine. Anybody have problem now? So these two are, that is what exactly I'm talking about. These two are completely, you can say these two are two sorted subarrays. These two are two sorted subarrays. Sir, we understood very clearly. What is that exactly? I am talking about why I'm talking about all these things, because I wanted to show how the merge algorithm works. Okay, merge algorithms, how it will going to work, I wanted to say. Now please here, see the procedure. Everybody observe the procedure now. It's very simple and easy. Now please see, we have a one sorted array from this side. Let's take this one as an array A. Okay, one sorted array this side, another one is sorted array this side. There are two sorted arrays are there. I'm talking about there are 4 elements here, also 4 elements. I have divided this one. This is the mid. If you go to this from here I to mid, nothing but it indicates this array, first array. Again mid plus 1, nothing but j to n, it indicates second array. Okay, that is fine, everybody. Okay, now see here, I wanted to sort now. I wanted to sort, nothing but I wanted to make one array. Please understand like that. I will going to create one more arrays here. Everybody observe now. Please observe now, everybody. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, na? So this is, I will going to say that this array is B array. Why I'm talking about this one, later you will get to know. Okay, later you will understand why I'm taking this array when we have a already array. So because here what I will going to do, I have a value here 10, index I. Yes or not? I have a value here 10, index I. Again here I have a value 11 here, index j, or mid plus 1, you can take it, no problem. What I'm telling you exactly, if I want to sort here, whatever the sorted element I will going to place in this particular array, nothing but I will going to identify which is less compared to these two arrays, which is less. That is what exactly I will do. Nothing but that is what exactly I will going to do the combine. That is what I will do. Nothing but comparison I am doing here. Comparison. The first thing is comparison. Understanding everyone? Everyone are getting or not? What I'm doing here exactly, we have one sorted array. This is one sorted array. Let's consider as a S1, no problem. This consider as a S2, no problem. There are two sorted arrays. That is what exactly I wrote here. Okay. I wanted to compare 10 with 11. Okay. Then which is the least one in this? Basically, okay. Again, one more important thing you need to understand about this one is which will going to take the first index over here. Suppose think like that. These are all the index 1, 2, 3, 4, 5, 6, 7, 8. Okay. In this, in this, you have to observe very very carefully. What is that? Very carefully you have to observe. Basically, you can able to sort when it comes to merge sort. You can able to sort in a ascending order also. You can able to sort in a descending order. Suppose think like that. I am doing in a ascending order. Okay, so here what I will going to do, I will going to compare this first index value, nothing but 1 with 11. So then which will going to take the first index here in the B array. So that is what exactly I have to find it. And that's why I will going to, what I will going to do, I will going to create a function. Okay, I will going to write a algorithm for this particular merge algorithm. Okay, what it will do, it will going to compare here whichever the least, nothing but lowest. Understanding in this S1, in this S2, you take it as S1 and S2, no problem. Otherwise, two are sorted array, this side as well as this side. Either you can call this one as left side or right side array, no problem. So first what it will do, 10 will going to compare with, please understand here, everybody, please carefully observe here. Okay, when 10 is compared with, okay, fine. When 10 is compared with 11, what happens here? Which is greater in this? Basically, 11 is greater. That's why, that's the reason why there is a code. You can able to see A of I right now. Okay, greater than or less than, you take whatever you want it. Again, A of mid plus 1. You can take like this or J also, no problem. Okay, so A of I is nothing but what exactly? That is 10. Okay, so 10 is less than A of mid plus 1. Mid plus 1 is nothing but what exactly? That is 11. 10 is less than 11. It indicates very clearly which is lesser in this. 10 is lesser. That is the reason why what it will going to do now, it will going to compare again, it will going to identify the least element in this both sorted array. Again, it will going to move this element. Please observe, it will going to move this element to first index. That is 10. It will going to store over here. This is the procedure. Okay, na? Nothing but what I will going to show you that one also, no problem. First, what it will going to do, it will going to compare with 10 with 11 like this. 10 and 11 it will going to compare. Okay, 10 and 11 it will going to compare. What is the least one in this? 10. It will take the first index. Again, that is 10 is over. Okay, now increment the value. Increment the I value, I plus plus. Where it will go? It will go to the 20. Okay, 20. Okay, compare with first index. Again J. Again J. Okay, 20 compare with again J. What is that? 11. Check the least one. Which is the least one in this? 11. It will go here 11. Again now, this is also over. Again compare 20 with the J plus 1. 20 with J plus 1. Please understand. 20 with J plus 1. What happens here? 20. I'm sorry. 20, 21. Understanding everyone? 20, 21 it will going to compare. Now you check it. Which is the least one? 20 is the least. Okay, it will come here. Correct or not? This is also over. 30 with 21. Okay, 30 with 21. 30 with 21. Correct? Which is the least? That is 21. It will go here again. again over. Okay, again 30 with, what is that? 31, which is the least here, which is the least here, 30, it will go here. 30 is also over here, 20 is over, 10 is over, here 11 is over, as well as 21 also over, which is left here, 40. Yes or not? 40 is left here. Okay, now take 40. 40 with 31. Check with 40 with 31. What is the value you will going to get it? 31. Put it here. Nothing but what? I am doing comparison here. I am doing comparison here. Again, moving this element to this particular array, that is called it as B. Nothing but move is a move also I am doing here. Move. Okay, I am comparing here. Again, moving that element into another array. Nothing but B array. Okay, that is what exactly I am doing here. Again, now check with 40. 31 also over. Right? 40 with 41. Okay, which is greater in this. Okay, 41. But least is what? 40. Take 40. Place it here. Okay, now what is left here? Please understand, these lines are very, very important. Nobody will say all these things exactly. See here. Now, what is the left with? 41 is left, right? Okay. With whom we will going to compare with 41? Tell me, with whom we will going to compare with 41? See here, 1, 2, 3, 4, 5, 6. 6 comparisons you've done. Yes or not? 6 comparisons you've done. Okay. But 7 comparisons you've done. What about 8th one? And see here, how many elements are there? Totally 8 elements are there. Please understand, totally 8 elements are there. But how many comparisons you are doing? Only 7 comparisons you are doing. But see here, so whatever the last element you got it, so you identify that this is the last element. Again, just you have to copy that element. Whatever the left element in this particular array, just you have to copy that element to this particular B array 41. Nothing but 7 comparisons are happening here. Okay. Okay, so 7 comparisons are happening. 8 elements are available. Okay. 8 elements are available, but movements, how many movements are happening? Only, how many movements are happening? 8 movements are happening. Okay. So that's why what I will going to do exactly when it comes to comparisons here, four elements. Everybody please observe now. So we have 4 elements. Yes or not? 4 elements plus 4 elements. Yes or not? Totally 8 elements done. Again, so these are all comparisons. 4 into 4 comparisons it will going to happen. Totally 8 comparisons it will going to happen. Yes or not? Again, -1. Why I'm telling -1? Because it will go into totally 8 elements -1. Nothing but totally 7 comparisons it will going to happen. That is what exactly I am saying here. So nothing but here, this array can I write like this, n by 2 half. N by 2 plus n by 2 half. Yes or not? Okay, -1. Okay, so that is the reason why please everybody please careful in this line, please careful everybody. Why I'm taking 4? These are all 4 elements are there. Here also 4 elements are there. How many for this one? Why I'm writing this? Because for comparison I am writing here. Oh, okay, I'm doing comparison, right? Okay, I'm doing comparison. For the comparison, I'm writing this one. There are 4 elements. We know that very clearly. Again, there are 4 elements. We know that very clearly. I'm comparing with this particular sorted array to this particular sorted array, left to right. But here, how many comparisons we did with the 8 elements? Totally, we did with the 7 comparison. That is the reason why I wrote like this: 4 plus 4 elements, nothing but left and right, -1 comparison. Totally. Nothing but what? 4 means, can I write like this, n by 2? So nothing but n elements are there. I divided into half. That is the reason why n by 2. Here also n by 2. Totally -1. That is what exactly I'm doing. Can I write this whole array or nothing but left array or right array, nothing but sub arrays, nothing but sorted arrays? Can I write like this? M plus n minus 1. These many comparisons, it will going to happen in the, what is that? Merge algorithm. Okay, these many comparisons it will going to happen. Very, very important. This is, I showed you very clearly. Okay, fine. Okay, so this is about the comparisons. Let's show the moves also. Okay, let's show the moves also. Okay, now see the moves. See, there are 4, 8 is there. So that is the reason why what I will do, 4 plus 4. Yes or not? 4 plus 4, that is equal to 8. Why? Because I'm telling you very clearly. 10 I did, 11 you can able to see. 10 I moved to B, 11 I moved to B, again 12 B, 21, 36, okay, 30, 31, 40. All the elements I moved. Again plus 1, you can able to see plus 1, one more element, 41. That one also I moved here. Yes or not? To where? B array. To where? It's in B array. So that is the reason why what I will going to do. 4 plus 4, that is equal to 8 moves are required. 8 moves are required to complete the merge algorithm. 8 moves are required. Yes or not? When I do the 8 moves, totally I will going to get the new array, that is sorted array. Okay, merge sorted array. Yes or not? So that is the reason why 4 plus 4 is equal to 8. Now can I write like this? 4 means n by 2 plus n by 2. Half. I am talking about half. Yes or not? N by 2, n by 2. Okay. Now finally what I will going to do? M plus n. Okay, these many moves we will going to do to sort a two sorted array. Okay, understood everyone? Very very important guys, this one. Okay, now finally here, finally what I wanted to conclude here, finally time complexity. What I wanted to conclude here for merge algorithm, I am talking about only merge algorithm. I am not talking about anything related to merge sort. Finally I will going to tell you about the time complexity is nothing but moves or not. Okay, time complexity is nothing but moves. Okay, understood everyone? Here time complexity is nothing but moves. Okay, so that's why what we are going to do, big O of m plus n. Just a moment here. Big O of m plus n. So this is your time complexity for merge algorithm. Clear? Here one thing you have to understand, it is not about comparison. It is all about moves. Suppose I wanted to get the final output like this. Here I wanted to get the final output is nothing but because of moves only I am getting this one, not because of comparison. It will going to compare again, it will going to give you something like that, which element you have to move to the array. So that is what it will going to conclude here. But finally number of moves it will going to give you what is that, exactly your sorted array. So that is what we got sorted array here. That is the reason why it says that very clearly. So what do you mean by time complexity here is nothing but number of moves. Okay, so that I will going to conclude here. Conclude here. Time complexity in this algorithm, merge algorithm, time complexity is nothing but time complexity means moves in merge algorithm. Okay. Now, so if you are able to understand everything, if you are able to understand, this is just what I'm doing. This is for worst case I'm doing. Okay, best case also I will going to show you. This is for worst case I'm doing. Okay, best case I will show you. Don't worry. Okay, worst case, nothing but each and every element is comparing here. Again, it is taking lot of time. Suppose think like that, if it is sorted and here also sorted. So I can able to directly do that. But this is a worst case. You wanted to know if the elements are arranged in this fashion, you will going to get a worst case. So what about the best case? That one also I will show you. Don't worry right now. Okay. Before that, we will going to write an algorithm for merge algorithm. Okay. So let's see that one. Okay. Now, so I will going to write a merge algorithm. Merge algo. So I will going to write a merge algorithm here. Everybody observe here. So first what I will going to do, everybody. Now see here. So we have taken here, everybody observe here. So J means what exactly? J is equal to, okay, mid plus 1. Yes or no? J is equal to mid plus 1. All those things I will show you. Don't worry, right? Okay, let's write this. While first I will going to write J is equal to, why I am writing mid plus 1, you people are getting right. Why I am writing J is equal to mid plus 1, I divided it into two parts. So next array, right array means I have to go to mid plus 1, then only you will going to get the index. That one I make it as a J. I made it as a J. Again, here I will going to say K is equal to 1. Again you can able to see I is equal to 1. Already you know why this one. Okay. K is a new index values. Okay, I will show you. Don't worry. What do you mean by K is nothing but, so we have an array. See here, we have an array, B array. So this I is equal, K is equal to 1. I will going to make it. Okay, na? K is equal to 1, K is equal to 2, 3, 4, 5, 6, like that. So that is the reason why I written that one. Now see. So this is okay for everyone. Now, while I think everybody understood the algorithm now. Okay, so the technique you understood. Now I will going to write an algorithm. I value, suppose I value, please understand here, please carefully observe here. Okay, I value, okay, less than or equal to mint. Nothing but what exactly this is? This is left array. This one you can able to see. This is the left array. This one. Okay, I value is less than or equal to mid. Okay, nothing but up to here I am talking about. Okay, and see here everybody. And okay, and I have to show the both the arrays, right? That is what exactly. J, instead of writing mid plus 1, can I write J? No problem. You can write J. Okay, J is less than or equal to N. So this is second array. Okay, this is second array. Fine. This is left side. This is right side. Over. Okay. Now everybody observe here. If okay, A of I, that is what I showed you. I have to find the minimum, right? In the two arrays, left side as well as right side, in the two arrays I have to find the middle, I have to find the minimum element. So that is the reason why I have to use the if condition or not. That is the reason why I'm using if condition. Suppose example thing like these two arrays, that's what I told you. This is left side, this is right side. Okay, here starting from I value is equal to 1, nothing but A of I, nothing but 1. Okay, currently what is the I value? Right now it is a I value is 1 now. So that is the A of I, nothing but 1. 1 is less than or equal to, or 1 is less than A of J. Nothing but what is this? A of J is nothing but mid plus 1, nothing but this element, J element I am talking about here. Okay, fine. That is the if condition. If A of I, that is what I told you, 10, you go to the previous if you want it. Okay, 10, okay, this 2, 10 is less than 11. Check it, 10 is less than 11. That is what A of I. Again, A of J less than. I showed you here. That is what exactly. Instead of using mid plus 1, you can write J also, no problem. Okay, na? That is what I written here. Okay, nothing extra. Now what we will going to do? If it is true, see here, that is what I told you, 10 and 11. Okay, 10 is less than 11. True, true. What you have to do? You have to move the element or not? You have to move the element to B array, right? You have to move the element. Then what you will do? I have to move the element. That is the reason why I will going to say very clearly, B of K. K is nothing but index. Now you got it. There is a one more array. That index starts from K. K is equal to 1, 2, 3, 4 like that. So that is the reason why B of K is equal to whatever the element is there. A of I, put that element into that particular array. That is the reason why A of I writing. That's it. That's it. That's it. Nothing else. Correct or not? That's it. Nothing. What is there in that? Over. If it is true, move the element into this particular array. Okay, sir. Okay, element we got here, no problem. Understanding everyone, element we got here, no problem. I wanted to put the next element. What we have to do? Nothing is there. Increment the K value, K plus plus. It will go to the next index. Yes or not? Okay. Again, okay, sir. This element I moved. Okay. This index element I moved to here. Okay. I moved to here. I wanted to go to the next index also. What we have to do? Very simple. There also I plus plus. Any problem? Any problem is there? Simple, na? Over. Okay, it's very simple. No. Okay, sir, we understood very clearly. No problem in that. Suppose there will be a condition. Think like that. I showed you the condition. That also I showed you. Yes or not? Okay. There is a some condition here. We can able to see 10 and 11. Okay, that is fine. No problem. 20 and 11. That is also no problem. Okay, here. You can see this one. This line you see. 20 and 11. Which is lesser here? 11 is lesser. Now I have to move this element to here, right? Then it is a false condition here. Yes or not? Now, for example, you take it as A of I is 20 right now. Okay. Again, A of J. What is that? 11 right now. Okay, right now. Nothing but I am talking about this and this. Okay, A of I is 20. Again, less than A of j is 11, which is less here. So basically 11 is less. Nothing but it is false or not. The condition become false or not. If it is false, where we have to go? We have to go to the else part or not. Have we created the else part? Till now, no, we haven't created anything like that. So that is the reason why what I will do, I will going to create the else part here like this. Else part. Okay. This part. Else part I created here. Else part I created here. So if the else part, how the else part will going to work? See here, observe here. That is the reason why I'm giving very detailed algorithm to you people. If this is the case, what we will going to do? We will going to push this element to array B, right? Yes or not? 11 will going to be moved to array B. That is what exactly we will going to do. So that is the reason why what I will going to do. That is the one reason which makes you push this right array, sorted array element into B array. How? It's very simple. B of k, already if it is incremented means it will go to the next one only. Okay. B of k is equal to, what is that value? A of j. Correct or not? A of j. That's it. Very simple. Okay. Sir, again I have to compare with the next element. What we have to do? Nothing. Nothing. Okay. That element is deleted. See here, everybody, this we got it 11, we got into this particular place. I have to go to this one, next one I have to compare. Means what we have to do? I have to increment the j value or not? Yes or not? I have to increment the j value or not? That is the reason why what we will do, increment the j value, j plus plus over. Yes or not? J plus plus. Again, those two areas, first here first element is over, again second element also over. Yes or not? First element is also over, second element is also over. Third index I have to fill. What we have to do? K plus plus again. Okay, that's it. Okay, close it. Your algorithm is done. Merge algorithm. Like this, you can able to do it, no problem. Okay, now like this, you can able to do it. Anyone have problem here? Please let me know. Anyone have problem? Please let me know. Anyone have problem in this? All right. I don't think so. You don't have any problem. It says this is what we call it as merge algorithm. Merge algorithm. So to combine two sorted arrays, to combine two sorted array, we will going to use this algorithm. What is that algorithm? Merge algorithm. Okay. So what is the time complexity for this particular merge algorithm? Please understand what is the time complexity here for this particular merge algorithm is nothing but theta of n plus m. That's it. Okay. So where exactly this one will come? I will tell you. Out place is there. Okay. Again, in place is there. Don't worry. Basically, this algorithm. Yeah, please. Please tell me. Any doubts, Pa? Naresh? No, right?
No, sir.
Okay, okay. I will, don't worry, I will explain. So these things I will explain later. Now you will not going to understand that. That is the reason why I will going to explain later about the out place and in place. Because the reason is, see, we have a algorithm, merge sort algorithm. Okay, merge sort algorithm. Inside the merge sort algorithm, what we are doing, I am applying one algorithm that is called it as merge algorithm. So this is a function actually. Merge algorithm is a function. Okay. Using this function, what I'm doing, I'm sorting the two sorted arrays. Yes or not? I'm sorting the two sorted arrays. Okay. Which is belongs to this particular array. Okay. One array, that is A array. Okay. I will going to sort these things. Again, I will going to get into the one more array. So this is what exactly we did. You can able to see this one. I already showed you, right? Here. You can see it. Yes or not? See, I sorted everything. Finally, where I got it? I got it in the B array. So this will going to take this much amount of time, nothing but m plus n amount of time. Nothing but inside the algorithm, merge sort algorithm, we are implementing one more algorithm. It is giving the worst case. Okay. it's saying nothing but what it's saying that suppose think like that there will be one family. Okay, in one family one person is there, he is the killer. Okay, so he is the killer. It indicates very clearly if this person is killing every day, nothing but think like that every day is bringing two dead bodies to home. Okay, what it means that all the people will going to think like that he is also his family also killing family, like that they will going to think. Nothing but what exactly I'm talking about here, this will going to give you the worst case. It means that very clearly even mud salt also belongs to worst case. Why? Because the reason is inside there is an algorithm. Inside that algorithm one more algorithm is there, that algorithm also giving the worst case. Nothing but whole algorithm itself is giving the worst case. Okay, that's why we're going to call this one as outplace. Understood everyone? Now outplace nothing but worst inside the inside one algorithm, that algorithm is not giving a proper one, worst case it is giving. Okay, so that is the reason why entire algorithm will going to give you the worst case. Yes or not? Okay, so that is the reason why I given this small example. Maybe you can able to understand very clearly about that. So that's why we will going to call this one as outplace. Merge algorithm is outplace. Okay. Uh, we will see next. Okay, so that is the algorithm. You can see this one, this is the algorithm, and we will see that one. Okay, best case, and finally we will going to write an algorithm related to merge sort. Again we will going to finish it. No problem. Okay, so just if you have any doubts related to this particular algorithm, you can ask me, and you can able to see here. Okay, so we will going to create the best case also. I will going to give the example best case, why it is called it as in place, all those things I will going to give you. Don't worry, uh, you will understand everything. Wait a minute, just a moment.